Welcome to today's algebra tutorial by Caz Academy. In today's tutorial, I'm going to show you how to use prime factorization to help you factor your trinomials. When we're going to factor a trinomial into a binomial, we know that we need to find the factors of a times c such that those two factors, when they multiply together, they're going to equal my a times my c, and that when those two factors are added together, they're going to equal my middle number b. Now this gets a little tricky when my a times c is a big number. And so you'll remember if my a equals 1, then a times c is just c, and we're going to factor the c, and that when my a is greater than 1, then we're going to use the a times c. That's going to give me a combined number that I'm going to factor. But either way, if my c is a big number, sometimes figuring out those factors can be a little bit tricky. So I'm going to show you two examples of how to factor trinomials, and we're going to use prime factorization to help us break down these big c values in order to help us find the factors to create our binomial. In my first example, I have w squared plus 4w minus 117. So let's label everything. So if I'm going to label everything, this is our ax squared, this is our bx, and this is our c. So we can see that my a is a 1, and we know that in order to factor, I need to take my a times my c, and since a equals 1, I just need a c. So my c is a negative 117. So I need to find two factors that when they multiply by each other are going to give me 117, and that when they add together, they're going to give me that 4. So let's write down what it is that we're looking for. So what I need is I need two numbers, an x times a y, that are going to equal a negative 117. And then those same two numbers, when I add them together, I want them to equal 4. Now 117 it's a big number, and it's not something that you would normally be able to know what the factors are. So we're going to use a prime factorization tree in order to help us break that down to figure out what its factors are. So I'm going to write down, this is 117. So if you don't know what to do as far as figuring out what numbers to do, what this might break down to, then it's always good to start with your prime factors. And there's a couple of shortcuts for factoring, so I'm going to just write those down. Shortcuts for factoring or simplifying. If they are an even number, then that means you can divide by 2. If it ends in a 0 or a 5, that means you can divide by 5. And if it ends in a 0, that means you can divide by 10. So that's going to really help us out to figure out, to help us simplify the factoring process. So I see that this is an odd number, so that means it probably isn't going to be divisible by 2, so I'm not even going to bother trying to divide it by 2. I'm going to go to the next prime number, which is a 3. So now I'm going to go and I'm going to see, does 117, can that divide by 3? So I can do my division, and I see yes it does. 3 times 39. When I multiply those together, those equal 117. Now when I add those together, those aren't even going to come close to 4, so I know that's not my factor. Now I'm going to take that 39, the 3 is already a prime number, and I'm going to take that 39 and I want to break that down. And I notice that this is a 3 and a 9. Both of those are multiples of 3, so that should be able to divide by 3 again. And when I divide that by 3, that's going to give me 3 and 13. So both of those are prime numbers. So that tells me that I'm done. So now I have found all of the factors of 117. So that tells me for 117, I can get 117 if I take 3 times 3 times 13. So those are all of the combinations. I can rearrange those numbers to form, and that's going to give me all of the factors of 117. So we've already discovered that when we're trying to find the factors, so remember when we've done the factors before, we wrote down the number and then we wrote it kind of like a chart like this. So we always know that we're going to have 1 times the number is going to be a factor. Then we found that we have a 3 and a 39. Now we can combine these together in a couple of other ways to see what else we can find. Now we can do a reverse tree by combining these two numbers together, and that's going to give me a 9 and a 13. And when I combine those two together, that's going to give me 117. So that's another set of factors. So you can see that when we do these factors, I can group them together. So right now, I can group those together differently. So that would make a 9 and 13. That gives me another set of factors. And then what we had originally, we had the 117. They were grouped like this to give me 3 and 39. So this is one pair of factors, and this is another pair of factors. And you can do this, you can move these numbers, these prime numbers around in any order. And then when you multiply them together to get two sets of factors. So we can look at our numbers. We know we're going to get 100. We want to get a negative 117. So in order to get a negative, that tells me that one of these numbers is going to be negative, one of the numbers is going to be positive, and I want to end up with a positive 4. So that means the bigger number is going to be the positive one. So what I can do now is I'm going to put a negative in front of each of those smaller factors, and I want to see when I add them together, are they going to give me 4? So if I add these together, so now let's do the adding together. We'll use a different color. If I take 117 plus a negative 1, that's going to give me 116, so I know that's not correct. If I have 39 minus 3, that's going to give me 36. That's still way too big. And then if I have 13 minus 9, I get a positive 4. So there we go. This is going to, when these are added together, that gives me my B value. And when I multiply these together, that gives me my negative 117. So that tells me that my factors are going to be a negative 9 and a 13. So that's how I've used the prime factorization to help me figure out these numbers. So now we're going to just go ahead and we'll finish the problem just like we've done before. So now I've got my 9 and 13. So now I'm going to take, so now I have my original equation, which was my w squared plus 4w minus a negative 117. And now I'm going to take the factors that I just found. So that's what I found down here. And I'm going to rewrite that as a binomial. So that's going to be w plus 13 times a w minus 9. And then I'm going to set that equal to 0. Those are set equal to 0. So I can use the FOIL method to double check that I've got those factors are correct. So that's going to give me w times w is a w squared, w times a negative 9, w times a positive 13, 13 times a negative 9, and we see that when I add these together, that's going to give me my 4w. So I just verified that these factors are correct. And so now I'm going to use my zero property rule to finish solving for my problem. So that means I make my w plus 13, set that equal to 0, and take the w minus 9, set that equal to 0 so that I can solve for my variable. This is going to cancel out, leave me with w, so that's going to give me w equal negative 13 is one of my solutions. And w equals 9 is my other solution. So my final answer would be a negative 13 and a positive 9. In this next example, we have the trinomial z squared plus 2z minus 360 equals 0. So once again, in order to factor this trinomial into a binomial, we're going to look for some factor of that when they're multiplied, the factor of AC is going to equal a minus 360, because this is our ax squared and this is our c, this is our bx, and that when these numbers back are added together, that they're going to equal 2. So that's what we're looking for. So we have our a is a 1, and our c is a negative 360. So once again, we are just having to deal with the c. If it was at AC, we would just multiply the coefficient that was in front of the z squared, multiply it by the c, and then we would factor that. So once again, we have a big number that we want to factor. So we want to break down this negative 360 and factor that to find two factors that when they're multiplied together, we're going to get a negative 360, and when we add them together, we're going to get a 2. So let's go ahead and use our prime factorization tree to help break this down. I know that it ends in a 0, so that tells me I know that it can divide by 10. So 10 times 36. I can break my 10 down to a 2 and a 5. Those are both prime numbers. I can break my 36 down to a 6 and a 6. And 6s are not prime numbers, those can be broken down again. So that's a 2 and a 3 and a 2, 3. And so now I have all of my prime numbers. So with this problem, those factor down much smaller or to a lot more numbers than what we saw with our previous example. So let's take a look at what we have. So we have 360 can be broken down to the prime factors of 2 times 2 times 2 times 3 times 3 times 5. So if we were to write down those factors just like we did before, we know that we can do 1 times 360, and we started with our first one, which was 10 and 36. Now from our prior grouping, when we're looking at our signs, we see that we're going to have a negative on the 360 and a positive on the 2. So that tells me that that whatever with my two numbers, one of them is going to be positive and one of them is going to be negative. My B is positive. So that tells me my larger number is going to be positive, the smaller number is going to be negative. So when I'm testing to see if they're going to add up to 2, if I have 360 minus 1, that's just going to give me 359. If I have 36 minus 10, that's only going to give me 26. So I know that neither of those are the correct pairs of factors. So what I can do is I can rearrange these prime factors in any way that I want. So you can go the reverse on this tree, or you can group them from the numbers. So let's look at a couple of possibilities. So when we're looking at these, we're going to go backwards. So what we can try to do is say, well, what happens if I put these two together? That's going to give me a 4. And if I pull the 3's together, that's going to give me a 9. And then I can bring that 5 down. And then what else am I left over? And then I also have a 2. Then 4 times 5, that equals 20. So that becomes 20. And this becomes 18. And then I can multiply this, and that's going to give me 360. So what I've done is I've just done the reverse direction on my tree. So what I've done is that the first time I did this, let's take a look at what we've done. We've got 360. Then when we grouped them, that was the same as grouping them as 2 times 5 times 2 times 2 times 3. And I grouped those together, my 2 times my 5 to give me a 10, and then my 2 times 3 times 2 times 3 to give me my 36. And that gave me my 2 factors. And I discovered that those weren't quite correct. So then I can try rearranging these numbers again. And so this time I decided to try, how about if I try 2 times 5 times 2 times 3 times 3 times 2. So I'm still using my prime numbers, but this time I'm just grouping them a little bit different. And that's going to give me 20 and 18. And that equals 360. So then I can go over here and I can put 20 and 18. I'm going to put my negative next to the smaller number. I'm going to test that out. 20 minus 18 gives me a positive 2. So that tells me that this is my correct pair for factoring. So going back to looking at what we did with the prime factorization before we move on to the binomial, you're going to take your number that you were given, your C, you're going to take your factor tree, identify what your prime factorization numbers are, and then once you have those prime factors, so that's what these are your prime factors. Then you can group those numbers in whatever way that you want in order to get different combinations to try to determine what is going to be the two numbers that are going to be the factors that meet the criteria of when I multiply them together, they're going to give me my AC, and when I add them together, they're going to give me my B. So I see that out of my problems, that my 20 and 18 meet my criteria, that when I multiply them together, they equal 360, and when I add them together, they give me my 2. So now I can go back to my original problem. So my original problem was z squared plus 2z minus 360. And now I'm going to rewrite that as z. So actually let's do an extra step here so you can see the whole process. Going the wrong direction. So now what I'm going to do is I'm going to replace that 2z with my positive and negative 18. So I'm going to take that z squared, and then I'm going to make that plus 20z minus 18z minus 360. So you can see that that's combined. When I add these two factors together, they're going to give me my 2, and that tells me that I've got that correct. So now what I'm going to do is now I've got everything that I need, so I can break this apart in order to create a binomial. And then the way that I can do that is I can do that by grouping. I can take my z squared plus, and I can take that minus 8z 360. And then I'm going to look for what are common factors that I can pull out. So this is a z and a z, so that means I can pull z out in front. That's going to give me z plus 20. And then on the negative 18z and a minus 360, I can pull out a negative 18, and that's going to give me z plus 20. So when you're doing the grouping like this, you want the stuff inside the parentheses, you want those to match. And then if those match, then you can take the numbers on the outside. So that's going to be your z minus 18 is going to be in one parentheses, and your z plus 20 will be your other parentheses. We're going to set that equal to 0, and then using the 0 property rule, we can set each of those parentheses equal to 0 and solve for our z. So that's going to be z minus 18 equals 0 and z plus 20 equals 0. Then we're going to add 18 to both sides. That's 18s are going to cancel out. That's going to give me z equals 18 as one solution. And then with this one, I'm going to subtract 20. That's going to cancel out. That's going to give me z equals a minus 20 as my second solution. And then my final answer will be do the negative first. So that 20 is negative. So we'll write it first because the negative 20 is a smaller number, negative 20, comma 18. And that's how you solve trinomials, using the factorization to help you solve for your AC to find what are the factors. So once again, you want to remember when you're factoring a trinomial, you're looking for two factors that when they multiply together, they're going to equal your AC, and when you add them together, they're going to give you your B. So that should be everything you need to know to use prime factorization to help you factor your trinomials. Thanks for watching. See the links below for additional supports and resources. Be sure to like and subscribe to get the latest videos from Caz Academy. Thanks for watching, and I'll see you at the next video.